And then now we are heading to 5.3.2. Says to us we need to determine sine theta. With all of that given information, again, you can also, in this case, you're gonna be obliged to use your identities. This is just for marks. You're gonna have to use your identities, right? Here's the thing. We have sine 2 theta is equals to what? Remember, this is your double angle, right? Again, if you forget how these double angles actually look like, refer to your formula sheet. So the double angle for sine, it's gonna be like this. Sine 2 theta is equals to 2 sine theta cos theta, right? Right. And then the double angle for cos squared theta. This can be like, don't be superhero, refer to your formula sheet. We can have cos squared theta minus sine squared theta. Another formula that we can make use of, it's when we have, where's my pen? 1 subtract 2 sine squared theta. And then another one that we can make use of is when we have 2 cos squared theta minus 1. So these are double angles, right? So you are given this double angle, and maybe you are looking for what? For sine theta. So if you take that double angle and then you expand it like so, the problem is you will be introducing your cos theta, and there is nowhere where we determine cos theta. So this could a little bit fail. But let's see if we introduce the cos squared theta double angle. So if we decide to introduce cos squared, not cos squared, cos 2 theta, if we decide to introduce cos 2 theta, we're going to have to expand it either this way, or that way. But the aim is we want to calculate sine theta. Can we expand it in this way? It will be fair. It won't be fair because, again, we're going to introduce cos, and we don't want cos. We are looking for sine. And then let's come here. If we expand our double angle in this way, will that be beneficial for us? Yes, because only sine, it is now visible and present in the expression. So this one is also totally out. So cos 2 theta, we can express it as 1 minus 2 sine squared theta. So let us make sine squared theta the subject of the sine theta the subject of the formula. I'm gonna take this one, 2 sine squared theta this side. I leave my 1 here, and then I take this one that side, the negative cos 2 theta. Then I divide both sides by 2. Sine squared theta is equals to 1 minus cos 2 theta divide by 2. And then I take root sign on both sides. I'm going to have sine theta being equals to 1 minus cos 2 theta. Recall you put your plus or minus, I forgot there, divide by 2. Yeah. Then now let's go. Now we're gonna substitute. You see, now we have sine theta, which is what we were looking for. So all we're gonna have to do right now is to substitute. Or you could have substituted at the beginning, it is still fine. It really does not matter. So now what we're gonna do over here is to further simplify this expression over here, we have plus or minus 1 minus cos 2 theta. Remember, we have determined cos 2 theta in the question above. We said it is this number over here, negative 7 over 9. So meaning we just plug, it's going to be positive 7 over 9 divided by 2. You see? And then plus or minus, we're going to have 9 plus 7 over 9 divide by, this is me writing this divide here, by 2, and then plus or minus square root of, what is 9 plus 2? 9 plus 2 is going to be 16. So we're going to have 16 divided by 9 Then this division sign turn into multiplication. We take the reciprocal 1 over 2. And therefore, from here, then what are we going to do? Let's not forget our plus or minus. 16 goes, when we multiply these guys, 2 goes how many times into 2 ones, 2 goes how many times into 16, 8 times. So we're going to have 8 over 9. And while we are there, sine theta in this case will then be equals to how much? Let's see. What is the square root of 8? Square root of 8 will be the square root of 8. Let's see if it was a cube root. We're going to have the square root of 8 and then divide by square root of 9 will definitely be 3. Therefore, this will then be our final answer. So at this point in time, we take the positive 1 because this is a double angle. So since when it is a double angle, you're going to take half of your interval. Your half of interval, this is 90. Remember, they say 2 theta is supposed to be between with this interval. So in this case, we're going to say theta, not 2 theta, is supposed to be between this element, 45 degrees. Why am I saying 45 degrees? Because the half of 90 is 45. And then the half of 270 is 135, and then here we write 135 degrees. Then you write that your theta is supposed to be the element within that interval. So if it is within that interval, then we are taking a different story. Instead of taking negative or positive, we can just take positive and substitute with our reason over there. So this is how we solve 5.2, 5.3.2.